Yerkes is the spiritual home of United States Hands-On Universe. Hopefully it can be at least kind of a spiritual rest for the rest of global HOUers. And a big part of that has been enthusiastic support from the directors, including Professor Kyle Cudworth. Kyle is a professor of astronomy at the University of Chicago. He was born in Minnesota and went to the University of Minnesota as an undergraduate. And then he came to California, University of California, Santa Cruz, when UC Santa Cruz was just being born, and he was one of the first PhDs to come out of UC Santa Cruz. And as far as one of the most long-term active alums from that program still in astronomy. And again, now he's been at University of Chicago ever since his PhD in 1974. He's been a hugely favorable host to us, support of all our educational needs. We're in ideas and planning stages on a number of ideas. But we want, again, I think all of us are so in tune with what we view as one aspect of the Yerkes mission that it's just a wonderful relationship. So let's thank Kyle right now.
Thanks, Carl. Mostly I'm here to do a real quick welcome to all of you. I see a lot of familiar faces out here because we've been for a decade or more, I suppose it's been, that we've been hosting the annual U.S. HOU meeting. So it's very good to have the global meeting here and to see a few faces that I have not recognized before, a few that I've met already, and I'm sure more of you I'll get to know as the week goes on. Yerkes Observatory, as probably all of you know, has a long history of over a century of being a research facility. In the past decade or so, we have very consciously been trying to move it to being much more science education and outreach center. And that piece of it involves a lot of things. HOU is a major part of it, but it's not the only part. We are doing lots of things with local high school students, one of whom is with us. We're happy for that. And we're also, that's partly supported by the local organization and partly by SOFIA Outreach, the Airborne Infrared Observatory. We also are partnering with George Williams College of Aurora University in a master's program for teachers with an emphasis on Earth and space science. As you can guess, we are the space science part of that. We've just finished a 2-week intensive course for teachers, and some of us are worn out from that and just trying to recover and enjoy this week and get even more worn out by the end of this week. And let's see, as I look around here, Kevin helped us all through that. Peggy helped us in the first week of that, which is an example of the mode we like to work in, of getting the experienced teachers in helping the new teachers. And I think that fits in nicely with the spirit of HOU as well. So, welcome to Williams Bay. I hope you will all get up the hill to Yerkes Observatory at least once, and I hope more than that through the course of this week. The forecast is for clear weather tonight, and we have telescopes that will be operating if the weather is clear. So, leave it at that, and I don't know who's up next. Rosa.
Download SalsaJ to their computers and install it. Here is the page where you find it. You go to European Hands-On Universe.
I might ask if anybody has not downloaded it.
Who didn't install SalsaJ yet? Okay. So you have time. You have time to. So the rest of you all have SalsaJ installed?
What version will you be using?
The last one, which is, if you go to the download page, 2.2 for Windows. You have also 2.2 for Mac and 2.2 for Linux. Okay? Okay, but this is not a session about Sun4all, about Salsa-J. It's a session about Sun4all. So I'll take some time to talk about this very nice project from the University of Coimbra. It's a university that has the heart of a node observatory in Coimbra that's been observing the sun for quite some time. And they produced a very nice exercise inviting students and teachers to use their image database to pursue several scientific objectives. So this PowerPoint, I'm not going to go into details in every slide I have, but this PowerPoint was produced and is a work in progress to be given to teachers, so when they are addressing some topics related to the sun, they can use it freely. So I have here slides that can be useful to elementary schools, like talking about the size of the sun and the planets, or going up to the secondary school level, where you talk about the structure of the sun, why we have so many phenomena on the sun. So everything is packed in this PowerPoint, and it's already you already have access to this PowerPoint. Is already on the web. I also have uploaded a few movies that are very nice. For instance, this one. I'm not sure that will run. No. Okay, never mind. I will show later because I moved this to another different location in my computer. But it's a very nice movie showing the latest explosion of the sun, a very huge burst that gave birth to this nice thing. I think these are very engaging images and situations to attract your students' attention towards your lesson and discussing why does it happen, what's going on the sun that makes things like this happen. So I'll go very fast through the slides that I'm mentioning because I don't have time to do each and every one of them. But again, I'm trying to include modern things, like for instance, this nice animation showing the sun rotating about itself. It's nice to discuss with kids that the sun rotates. How can we spot that? Can they do that by themselves? So you can discuss the life cycle of the stars. Talk a little bit about our sun, the life cycle of our sun. As you see here, this is the path of the life cycle of a low mass star, like our sun. You can discuss that further. Again, I'm not going to do that now. I have I'm pretty sure all of you know the sequence of images that shows the sizes of the planets, and then to compare the size of the planets with the size of the sun. And this is what that I've been using very often when in my latest teacher training sessions to help teachers promote discussions about 2012. I'm pretty sure you all heard that our world will end in 2012, right? So this is a nice image to promote discussion with the students and have them understand what would happen if it's not the case. The planets are not going to be aligned in December, which is a pity because to us astronomers, amateur astronomers, would be wonderful to observe them. But what would happen if that really was the case? And so have them take a look at this image and discuss what would happen and realize how ridiculous the whole 2012 thing is. Then this sequence that shows the size of the sun compared to other bigger stars, and the big overview that tells us that there are stars that are smaller than the sun bigger than the sun, blah, 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 blah. So, again, I'm apologize for this, but in half an hour, I think all of this you can do by yourself. What I would like to share with you is the actual exercise. The exercises are based in following and measuring things like the solar spots, the prominences, the solar ring, coronal mass ejection, trying to put students hands-on measuring and calculating things using these solar activities. You can have your students, for instance, observing, actually Sun4all can be done with Alpha-J, can be done using PowerPoint and Excel spreadsheets, and can do is just printing the images and using them in paper, taking it to the school and have the students making measurements. And one nice thing, for instance, is if you have a Galileo scope and you attach a filter to it, Radarr filter, you can observe the spots in the sun. You can have the students draw what they observe. You can project the sun and have students draw it, and then they can calculate the size of the spot and compare it to the size of the Earth. This is usually a very teachable moment when the kids discover that, what the hell, that spot is bigger than our Earth. Can't be something wrong here. And usually we don't tell the kids. You shouldn't tell the kids. You should have them outside, tell them about safety, about observing the sun, let them observe, let them sketch what they are observing, and then you tell them what is the size of the sun. They calculate the size of the spot, and then you tell them the size of the Earth, and they go like, what? What is this? So it's a nice inquiry-based science education method. Okay. Quickly here. You have this to use, so you can use it freely. I have two movies that are uploaded already. One from NASA, JPL. Let me show this quickly here.
So can you ask a question?
Sure.
You know, I'm not sure I have a good way of doing that, but when we do scale size courses, or we use portion of scale a lot, those are probably some of the biggest, most important ideas in, primary school math up to high school, portion of scale. So this is such a, what your sunspot thing, fantastic proportion of scale. I wonder, I would hope, we go over, all of a sudden, kids are just given formulas which they memorize while and they don't think about the proportional scale versus a handicap. I hope we can make sure we take time to let them understand what the proportional scale are mathematically.
Sure, it's a great idea for the use of these exercises.
Yeah, the math teachers are happy.
Of course.
Do you need sound?
I need sound. Yes, please. Thank you. Am I killing the sound in the people?
No, that's separate.
Okay, so this, I've added two movies, one from NASA and another one from ESA. I'm not going to show them entirely, but usually I find that students like to have a small movie, show it, and then you discuss it, and then you show pictures, you have them measure things, you show another movie, so it's a nice way to interact with them and show the ideas that you're willing to share. So this one is from NASA, and it was produced during the International Year of Astronomy. They have What's Up in the Sky this month. So this one talks about solar spots and the history of solar spots. This is a small one.
Hello and welcome. I'm Jane Houston Jones at NASA's Jet Propulsion Laboratory in Pasadena, California. 2009 is International Year of Astronomy. Each month this year, we'll take you on a tour of one of the best celestial objects on view. This month, it's our star, the Sun. Galileo and Englishman Thomas Harriot both observed the Sun and sunspots in 1610, but they weren't the first. Chinese and Korean astronomers wrote about sunspots almost 3,000 years ago. John of Worcester, who was an English monk, made the earliest existing drawings of sunspots in 1128. Galileo's solar observations of 1612 were made at the same time of the day every day, and so the motion of the spots across the sun can easily be seen. This motion allowed early astronomers to estimate the sun's rotation period, which is about 27 days. The early astronomers soon projected the sun's image through the telescope onto a piece of paper or through a pinhole projector. This made it possible to study the sun in detail without damaging their eyes. Many other astronomers in the 17th century, including Scheiner, Gassendi, and Hevelius, also recorded their solar observations. More than 24 past and present NASA missions explored the Sun-Earth system.
Okay, I'll stop here. I couldn't find this movie in NASA webpage. I had some hard time downloading it, but I gave it to Alan, so I think he will upload this in.
It's already uploaded.
Already uploaded. So you have access to that. That is a very nice one. We talk about NASA's missions.
So that you know, anything that we're uploading is going on the abstracts page of this conference. Global Hands-on Universe Conference.
I can show it later. This other movie, it's an ESA podcast. ESA is producing a series of podcasts. They are all very nice about different topics. It's very easy. If you Google ESA podcast, you'll find it. And this one is about the sun. Again, I'm not going to show it completely, just so that you have a taste of what you have here.
Hello, I'm Rebecca Barnes, and welcome to the Science at ESA podcast. In this episode, we'll investigate our closest star, the Sun, find out why it's the central engine of the solar system, and look at Ulysses, SOHO, and Cluster, the European space missions that have been key to advancing our understanding of the Sun. Life on Earth relies on the Sun for light and heat. The energy released by our nearest star has allowed humankind to survive for hundreds of thousands of years. Today, we seek to understand how the Sun works, why it changes, and how these changes influence us here on Earth. Some of the variations of the quality and quantity of light from the Sun over short and long timescales most certainly affect the Earth's environment, but the how is uncertain. With the dawn of the space age, we learned that the Sun also affects the space environment around our home planet. The conditions on the Sun, the solar equivalent of wind and storms, can influence the performance and reliability of the technology and satellite services that our lives are becoming increasingly dependent on. Despite its critical role in our lives, the Sun is just an average star. More specifically, is a small yellow dwarf star located on the main sequence of the Hertzsprung-Russell diagram. It is by far the largest object in the solar system. With a diameter that is over 100 times that of the Earth, the Sun contains 99.8% of the mass of the entire solar system.
The most dominant...
Okay, so I stop this here, and again, you have this video as well available to you. As I say, all the podcasts are really very, very good, and I think you will find it very handy to you. Okay, so going back to our exercise, I don't know if you noticed, but that will prevent me to having to explain to you something that I don't know, which is the explanation about the solar activities. Sun is a very complicated star, and phenomena in it can be really very tricky to understand. But what you see here in this image are filaments. Basically, you're seeing these prominences. If I was to see this prominence here from above, I would see them as filaments on the structure of the sun. And using Sun4all or Sausage, you can measure the size of this filament. Okay, so I'll go quickly here. Okay, one of the activities of Sun4all. Okay, so this is Sun4all, and I will show you the website where you find all the Sun4all material, supporting material. So if you Google Sun4all, okay, which I did, Sun4all, you just Google it. I did that. I can do it with you, so you know. Sun4all. Already the first one. I enter this page, and then you see a page that can be in Portuguese or English. If it appears to you in Portuguese, you just click here on the flag, and it will bring you to this page in English. And you have here is where you go to the database of images, which I will talk in a second. And here is where you find the supporting material. This page is not presently completely updated, but here's where you should refer to in the future. You can also find the material that we will be using today in Galileo Teacher Training Program webpage. If you go there and you click on Resources, and in the Resource tab you choose New Technologies. This is also a type that needs to change a little bit, but to make your life easier finding things, you go to next page. I think it's the second page of New Technologies, and you find here Sun4all. Sun4all, everything together. And here you find updated versions of the things you're going to be using today, okay? So the appendix that you will be using today with me is the one you find here in this page. I will come back here with you in a second after I explain to you everything that you can do with Sun4all, okay? So I showed you where you find the web page of Sun4all. Yes, Sun4all. You have some reading material here in the PowerPoint presentation that you have, explaining to you where you find all the negatives, all the images that you need to perform your activities. Actually, you have images since 1920 till 2007, I guess, already uploaded, and the rest is work in progress, but in a few months from now, you will have images since 1920 till today. So you can, for instance, go with your students and check how was the sun the day they were born. Did they have spots or not? For instance, it's just an example of things that you can do, okay? This is a little bit of the history of people that founded the observatory in Coimbra. It was a professor, Francisco Miranda da Costa Lobo, helped by the Landry, a French scientist. Not going to explain this all to you. So this is the database. You have K1V and K3 filter images from 1926 until today, and from the 80s on, you have age alpha images from the sun. Okay, so the activities, the number of activities will grow in the very near future, but you now find one activity which is counting the spots on different days, and therefore measuring the change in activity of the sun. The more spots the sun has, the bigger is its activity. When it has no spots, as happened in 2009, 2010, was boring sun, no spots means that the activity is very low. Okay? It teaches you how to calculate the index of spots. Here's an example. You can print the image and have the students count the spots in different groups and how many groups it has, and coming up with this index. The second activity is to have them calculate the 11 cycles, which was something that scientists believe was very well defined, but then it's not, because the Sun was supposed to have regained activity in 2009, and it didn't. It took some time to regain activity again. But you can see why scientists found out about the 11-year cycle by simply counting spots. Take the large database and count the spots. One pretty neat thing about this database is that the telescope is sitting there taking pictures of the Sun, and the majority of the time there is no scientist looking to the images. They're just sitting there waiting for your students to go there and make new discoveries. Some of the images have never been seen by anyone before. Okay, so the 11-year cycle is another interesting activity. It guides you step by step how to reproduce the graph with the 11-year cycle. The activity 3 is to do the same thing but using the spectroheliogram, meaning another filter. Activity 4, which you will do it with me today. Did you remember in the movie that I showed? They showed us different drawings by Galileo and how we see that the Sun is rotating. Well, you can go retrieve his drawing and using Sun4all produce a movie that shows the Sun rotating. We're going to do that here today. You can also analyze the solar spectra and find out teach about when we see that something is being absorbed or something is being emitted. We will build today actually a pretty neat spectroscope that allows you to see this. Okay, you're going to take home a cardboard spectroscope that will allow you to see the Fraunhofer line. Okay, I don't want to go into detail. We are going to see some images like this and measure this prominences. See how big they are, also using Sun4all. Another very interesting activity that you should do with your students is evaluate the solar cycle versus climate to see to promote discussions about climate change. So you see that the average temperature follows more or less the activity of the Sun, except from 1980 to today. There's something going wrong, probably us, right? So it's a good point for discussion. Are we responsible for that? No. So it's a good thing. Again, you can do that without computer. Just need, to have some information about the images and build your graph. Okay. So I guess we go with no further delay to the activities themselves. Everything that I'm showing here, every little thing, is in the guidebook, which is in English, and it was translated in English, thinking about EU HOU. Okay? We are the international partners of this project. Okay, we're in good collaboration with you. Okay, so I want you now to go to GTTP webpage and find the Sun4all, and I want you to download this appendix here. Okay?
So what's the website? Galileo Teachers?
Actually, I'll go again. I want you to download both. One is the file containing the instructions, and the other is the file containing the images. Okay? So I'll go step by step with you. You go to www.galileoteachers.org. The reason why I'm going to Galileo Teachers and not Sun4all is because they don't have the updated appendix using the new version of Sun4all. Once you are in Galileo Teachers page, you go to Resources, go to New Technologies, the second or third page. You find here Sun4all, and you have here download the Sun4all with Alpha J appendix and images to be used with the appendix. I'm going to do this with you. I'm downloading the appendix. Oh, this is the image. Oops. Did I do something wrong here? Yes, I did. No. This is the appendix. So we're going to follow this appendix step by step.
What's the link on the GTTP website?
www.galileo.
No, which tab after we are there?
Resources,
Resources.
new technologies, second page, Sun4all. Okay, so I'll go now. Just a second. No problem at all. Let me just open the appendix in a more friendly format. So, who is having difficulties finding it? Everyone has it already? No?
What are the images? What are they titled?
It's this file.
And then what are the names?
Oh, they're inside. They have K1, K4.
I'm getting a mirror. I'm getting a mirror when I this on my mirror.
Okay, so let's do the following. I will do the exercises, you watch me, and then we will provide all the images to you and you can do it yourself, okay? Tomorrow we have a session on Alpha J. The images are all on the website, right?
Yeah.
We'll try to make sure that
hopefully they work.
well, no worries. For tomorrow, we have a Alpha J session, and what we will do with you is precisely that. Have you do what I am going to do here. Okay? Is that okay for you? Good. Okay, so I'm going to launch Alpha J. This is a new version of Alpha J.
Why is it Alpha J? This image J, why Alpha?
Now, Alpha this was an adaptation. The program is based on image J, but was produced to have certain features for astronomy. So the acronym goes for such a lovely software for astronomy.
Really?
Yeah. Okay, so here you have.
I think we'll learn this from my Mac, no problem.
It says Windows 10 on the system.
Once again,
We get that.
spoiled by the
Mine's working.
Okay, so the first activity is. I'm going to scroll down here. So we're going to count the spots using images from different days. So you open Alpha J, okay, and then I am going to open one of the spectral heliograms that you should have saved in your computer. So it's this one called. Let's see which one. A K1V12. So anyone managed to open the images? No. Nobody. Okay, so I'm going to open Alpha J. I click here in the open. open tab. And I'm going to open this image here. Open. One thing that is important, in this case, these images are all JPEGs. Okay? If you go to the image directly and do click, it will not open in Sun4all. It will open in your regular picture viewer. In order to open something within Sun4all, you have to do it as I did. File, open, go there and open the image. Okay? You also tomorrow will be working with fit file. I will explain that tomorrow. It's a special format for where you actually get to manipulate the image. And that also, if you click, it will not open with Sun4all. Okay, you have to go like this, file open. Okay, so I have the image here open, and then, so as you see the appendix, show you step by step. I'm not seeing what I have in the screen.
I'm not.
As you have. Wait a moment. I just went too far down. Okay, so.
What image do you want to open?
It's that K1 V12 something.
Okay.
Okay? And then, after you open this image, so you did manage to open.
Yes.
Okay.
And I'm on a PC.
Okay, so what I want to do now is, I go back to Sun4all. I should have the appendix printed here. Can we have some of the appendix printed tomorrow for the people? I think it's easier if you can read and do it in the computer both at the same time. It's frustrating because in my screen, for instance, it is very frustrating. Okay, so now I go to Edit. And for those of you following me, okay. I want to go to Image. I go to Lookup Tables. I go to Edit Look. Okay, Lookup Tables. What I'm doing here is I'm going to change the way I see the image. So I open this and I say invert. So I'm seeing the negative of the image that I have. It makes it easier to make measurements. Okay. So I've used this feature to invert it. So now I have the negative image. Now I'm going to zoom in into the image, okay? So again, I go here. I click in the magnifying glass here, okay? And I zoom in a little bit. Okay? Now, I use this hand here to position the image that I wanted. Okay? And now I'm going to draw a segment. So I clicked in this thing here. If I use the right side of my mouse, I can choose other options here. Okay? I want a straight line. I'm going to draw a straight line here. Okay? So again, following what is in this recipe, you draw a segment passing in the sunspots. Okay? And then I want to see the plot profile of this. Okay? So basically, I will count the spots that are in that segment using this plot profile. So I go to Analyze and Plot Profile, and here you go. So I would say I have one spot, and if you see here in the screen, here you see the yellow circle. As I move my mouse on the graph, the circle moves along the segment, telling me where I am. Are you all following?
Yeah.
So I have one spot here. I could say I might have 3 spots here, right? So you can analyze in that way. This makes it much more much more correct answer when you are counting the spots, because it can measure things that your eye perhaps is not so sensible at measuring.
I just did surface plot. You rotate it
You
around.
can do that, yeah.
Very, very.
Exactly. You can do that as well. Okay. So now the next thing that we do, zooming, and this. So now we are going to make a movie. Okay, so now what you do is you open 4 images that are a sequence that you've taken in sequential days, okay? And so you go with alpha J. And my suggestion to those of you that have things open, close the plot, close the image that you've opened before, and open. And when you have your images, after you pass an enormous amount of time, you must have it somewhere there. Fine. Open. Okay. Now, if you see this are sequential images. This one was retrieved on November 21st, 1992, 22nd, 23rd, 24th. Okay? And I open all these images. Okay? So they are now all open. And then what I do, following the recipe, I can invert the lookup table again or not. I would choose not to invert, not to waste time, because you need to go in each and every image. And then you go to image, stack, images to stack. Okay? So I go here. Let me minimize this one. So I go here and say image, stack, image to stack. And voila. If I click here, I see my sun rotation. Pretty neat, huh? Imagine that I've added a stack that doesn't belong here. For instance, imagine only that this was a completely different image of the sun, was a mistake. I can go here, image, stack, select twice, and it's gone. Or I can go here and say image, stack, and go stack to image. And I have my images again. Okay? And you can do that with any JPEG. This goes for the sun or for a kid running around or anything you want. Goes for the asteroids as well. The kids have been trying to blink the images and see if they could see something. Okay, going back to our recipe. How am I doing relating time?
Well, 9 is 11:38.
So how many minutes that I have? I don't know.
That would be.
95.
Let's see. No, I mean, there's nothing between you and lunch. I mean,
okay,
you have till noon.
And then, of course, you can play with the lookup table and make the sun look as nice as this one, changing the lookup table. Yes, Carl?
I don't know, to get the time frame when you do a stack. It gets in order somehow. You can check.
You can invert you can change the order of your sun.
But I just,
because they were sequential images.
Right.
That's why it was
But
perfectly
sometimes it's knowing what order they're in. And I'm not sure.
I mean, if you want to make a movie, you want to be sure that you have solar images in subsequent days. Otherwise, you won't have a...
Is the reading a bit better with the time on it?
No, no. It's just stacking images one after the other. If you have a mouse, a car, and then a hand, it will appear one after the other. It's already open. Yeah. Okay, so you can change the lookup table if you want. You can play this. So this is just playing with the colors of the image to suit your needs, depending on what you want to see, okay? Okay, so now the last exercise that I'm showing you here is to measure the prominences, measuring a prominence of the sun. So again, I will close all the other images. Okay, I'm closing this one. This one, and then I'm going to open an image, an age outcome image. Sorry, no, K3 image. This is the one I want. Precisely this one that is on your appendix. Okay. So what I'm going to do here is I'm going to increase, to zoom in, move it a little bit because I want to measure this prominence here. I'm going to zoom in a little bit more. I'm going to retrieve my hand again. And again, I can use the slide. And I can come here and measure this. Okay? And then, what I do with this, find that I have the recipe for this. Okay, I have another one. Okay, so having the image showing here, I can go to analyze, and I can click measure. So here you have the measurement, the size in pixels of this prominence, okay? Now, of course, you need to have some other information, like your pixel scale, to know and make measurements in your unit, okay? But you can, for instance, one thing that you can do with the kids, elementary school kids, for instance, if you hit Control and the zoom, the magnifying glass, you decrease the size, okay? I can play, making something like, try to draw it very properly, more or less like this, and measure the size of the sun in pixels, and compare to the value I know. Okay, if I hit here, Analyze, Measure, I can say that my sun has a diameter of 478 pixels in this pixel scale. So, because these are JPEG images, I don't have information. The header that Carl was mentioning is not in this image. They are all JPEG. But you can retrieve images of the sun in PIT format. I'm not sure if Coimbra Observatory have them, but they might. They might have it, and you might be able to retrieve with the information pixel scale. You can also play with the sun and try to make a full measurement of the whole disk of the sun. Okay, this is obviously not very accurate, but gives you the area more or less, accurately enough. Okay. Okay, so this is what I have for Sun4all, and I would advise you to try and do it yourself. If I give you the date, you can go to the website and retrieve the images directly. So what I will do now is I will leave my folder open so you can see the dates of the images. like here. So, for instance, this one was December 27, 2001. The filter was K1b. So if you go to the website, let me open it. So 27th of December 2001. I go to Sun4all again, click here, and I'm in the database. So I want December 2001. Oops. Oh, no, sorry. I want to go here, solar observation. Hope it's on. They had to change servers. Okay. So I want the month. No. But month is 12. Year 2001. Month is 12. 2001. And I want the K1. Okay. And here you are.
This is how you can learn the names of the months.
You can learn the names of the months. That's true. So I want the one from 27th of December. So let's see. This is the one that I have. If I click here, I have the image, and I can save it. Okay? In this way, you can retrieve all the images. So I'll leave this open for you guys that couldn't download the images, and you can go and retrieve your own images. And I'll go circle the room now, answering your questions.
Someone put those images on a jump drive, so those of us who couldn't get them.
I have that.
No, Kevin.
No, right here.
Kevin did.
Oh, okay.
So he passed it around, so I think most of them get it.
Everybody happy?
Okay. So what I suggest now is that you try it yourself. Try to do it. Yes, please.
I'm wondering if all the images that are on the website for Sun4all, are they all from the same observatory?
Yes. They're all from the same. It's Coimbra's observatory. All the same telescope.
Okay.
Although they have been putting new filters and remodeling the observatory, good new things are going to come, but they're all from the same. So it's a huge database, actually a huge database.
And they've been pretty much continuous operation?
Yes, every day, every single day, except when it rains, of course. Very good. So questions?
I think we can actually break early with questions. Whatever questions there are, but we can have an informal until lunch. Yeah.
I suggest that you try to do the exercises so you start getting acquainted with Sun4all. There's no manual for Sun4all yet. And I think the developer's idea is that you start trying using features by doing the exercises, and you start getting acquainted to Sun4all.
Also, if you have questions at this time about the Stellarium session that Rich Lohman did, this would be a good time, too.
Perhaps if you have questions, you should ask loud so people following us on the web can also hear.
Yes.
No one has questions. Lots of people. Go ahead. Start.
son trying to download the images and you couldn't do it, or you're gonna, mine came down, but they wouldn't open it. The WinZip wouldn't open.
Hey, Ken, maybe you can unmute.
Well, I was thinking, it's nice to know.
Hey, Rich, did you get that file? I mean, do you have a jump drive to put the file on? I mean, actually, he can't hear me.
Yeah. It's the one that we did. Never the
handout. Okay. Hey, Ken, I want to see if I can hear you as a side conversation here.
Thank you. Please stand by.